I'm going to be talking about multiplying roots. Now, exactly how do you multiply roots? If you have the nth root of a times the nth root of b, it would just equal the nth root of a times b inside one root. This works as long as those numbers there are the same. Okay, so I want to explain why does this work? Why does this property work? In order to explain why that property works, I'm going to end up using the transitive property. And the transitive property basically says that if you have a equal b and you have b equals c, then you know that a is equal to c. Another way of writing this part right here, I can write if a equals b, and I also know that b equals c, then a will equal c. Take a moment to write down this transitive property if you didn't know it before. Hit play when you are ready. Okay, so back to multiplying roots. So why exactly does this work? Well, let's use an example to explain. So if I have the square root of 3 and I'm going to multiply it by the square root of 3, well, I know that this is equal to parentheses square root of 3 squared. This 2 right here just means the thing inside the parentheses is happening 2 times and they're being multiplied together. So I know this one and this one are equal. All right, and I also know that this right up here is equal to 3. I know that because the exponent 2 and this square root are opposites. They're inverse operations, so therefore that square root and that 2, they will sort of cancel each other out and you'll just have that 3. Okay, I also know that another thing that is equal to 3, I know that square root of 3 times 3 is equal to 3. There's a tiny 2 right here, which means for every group of 2, 1 will come out. And then there's nothing left inside the square root once this comes out, once that pair comes out. So finally, using the transitive property, because I know this is equal to this, and this is equal to this, and this is equal to this, using the transitive property, I know that these two, this line and this line, are equal to each other, which matches this exactly. Pause the video at this point, write down notes, hit play when you're ready. Let's do another example with something other than square roots. Let's say that you have the fourth root of 7. And let's say we have that multiplied together 4 times. So fourth root of 7 times the fourth root of 7 times the fourth root of 7, 4 times. Okay, and I know these 4 things multiplied together is equal to the fourth root of 7 to the fourth power. Once again, this 4 means the thing inside the parentheses is shown 4 times, all multiplied together. Once again, this exponent 4 and the fourth root, they're inverse operations, they're opposite operations, so they undo each other or cancel each other out, and all you have left for that is 7. So these two are equal. I also know that this right here is equal to the fourth root of 7 times 7 times 7 times 7, 4 times. This 4 right here means for any group of 4, 1 will come out. There's nothing left inside, so these two are equal. Using the transitive property, because this is equal to this is equal to this, and this is equal to this, I know that these two are equal. This is part of the reason that we need the root to be the same. We need a little number in there to be the same for them to add together. We need that little number to be the same to multiply together. This sort of reasoning. Okay, so take any notes you want at this point. About dividing roots. And how do you divide roots? Well, if you have the nth root of a divided by the nth root of b, it becomes the nth root, one big root of a divided b. This is how you can turn two roots divided by each other to one root. Now exactly why does this work? Okay, it uses very similar reasoning to that of multiplying roots on why they work. So let's say, for example, you have this starting off. So you have the third root of 5 divided by the third root of 2 to the third root. Okay, well this 3 right here means the thing inside the parentheses happens 3 times and they're all multiplied together. So therefore, that is equal to that. The thing inside the parentheses, 3 times, multiplied together. Using the rules for multiplying fractions, I know that these 3 fractions multiplied together, I can just write as the tops together, multiplied, and then the bottoms together, multiplied. So let's write that. Let's put all the top together, but multiplied, and then all the bottoms together, multiplied. All right. So if I'm looking at the top here, you have the same thing 3 times. So I can write this as just that to the third power. So let's do that. So the top of this fraction is equal to this, because you have the same thing 3 times. Same thing happens with the bottom here. Third root of 2 happens 3 times. And so I can just write that as the third root of 2 to the third power. Now, at this point, you've seen the thinking before. This exponent 3 and this third root will cancel with each other. So then at the bottom of the fraction, you just have a 2. Same thing for the top of the fraction. This exponent 3 and this third root are inverses, so they undo each other, and all you have left on the top is a 5. Okay, and I know I can also write this like that. For the same similar reason, I know that this exponent 3 and this third root are opposites, so they would undo each other or cancel, and all you'd be left is 5 over 2. So all of these here are equal to each other. And so using that thinking, I know that this one that we started with and this one that we ended with, those are equal to each other. Now let's take a look at the thing we started with and the thing we ended with. Now both the thing we started with, it was something in parentheses to the third power. This thing we ended with was also something in parentheses to the third power. Because we have both of those as something to the third power, I know that, let's use orange, I know the thing inside of parentheses must equal this thing inside of parentheses. So this part that is inside of parentheses third root of 5 divide the third root of 2 must equal this thing inside of parentheses. Third root of 5 over 2. And there you have it. There is an example of our dividing roots rule. 2 roots divided together that have the same little number there can become 1 root with the same number there, and they're just divided inside the root instead.